It's a rainy season here in Jamaica, which exists within the Caribbean. But this content is not just relevant to the Caribbean or the Atlantic hurricane belt. It also has relevance to other regions, such as in the Pacific, Indian Ocean, as well as areas that run through China, Japan, to name a few. What you should now be aware of is that there exists geological proof of ancient storms, and our riverbanks are key holders as regards to holding the past record of proof for these past or ancient storms. So in this video, I'm going to be giving you insight in terms of how to actually be able to identify same. Look at the riverbank to the left of this video here and pay close attention. You will see larger boulders, and basically you see as it goes upward that you can't really see the boulders as defined. Now, just for your understanding, where I was basically in the riverbed, and this is the dry season. And what it is that you could see or you can see are large boulders on the riverbed. But then to the flanks of the riverbed, the left, you see the boulders also pretty much cemented. Now that cementing indicates that those are older boulders. In other words, that's proof of historic storm event. At the riverbed here, you can see what I'm looking at exists two main types of uh, stones. We can see the larger boulders, which are what we consider as sub-rounded to angular, and then we can see more rounding. Now, what it is I am showing here in this image is basically a vertical view of the river bank. And I want you to pay close attention, whereby you can see basically different sizes of rocks. These different sizes of the rock indicate the general energy of the river in the past. So if you had a river event that would have been much more forceful, it basically can move larger rocks relative to it being in a much more quiet state, whereby it will then move smaller sediment. So you can see basically those layers where you have bigger rocks, and we can then see those layers that we can pretty much identify as being sand. And that gives general insight into the reality that you would have had a storm, or you would have had flooding events, and then you would have had much more quieter events reflected by the sand deposit size, sand grains. The reason why it is key for you to be able to identify or to recognize this is because, especially in the context of our development, I mean, yes, in specific to Jamaica, but even that can be reflected in multiple geographies across the world. Development in terms of community development, agricultural development, infrastructural development tend to predominate on floodplains, and these river banks basically tend to be what eventually become floodplains in many of the areas that we develop. So when you can understand the sediment, you basically understand what took place in the past and what is likely to take place in the future. Now look at this image, and what it is that you should now see are even larger rocks. Rock size that even looks as if to say they are boulders. And these boulders exist over the finer sand grain sediment layer, and then they also exist over a relatively larger sediment layer that is in relation to the sand grain. Now, with these large boulders, you can take it that this is proof of past storm event. Now, another key indicator of my storm deposition hypothesis has to do with the direction that we can see these boulders are actually pointing. And basically, this is what we consider as imbrication. So, in other words, uh, the flow of the river would give an indication, I will leave remnants in terms of how the rocks or the sediments would position themselves. You can see with these boulders that you generally have a tilting from right to left. However, there also exists those smaller sized rocks that showcase that they don't necessarily have that tilting, just the same, that general resemblance of the majority of the larger boulders. And this basically can give indication to the reality that you can have eddies or circular currents. So again, that basically highlights that the force of the water is significant, that even though you basically have the general movement of the rocks themselves or the sediment themselves, there are still those sections within the floor of the river at the time of the flood that basically provide those circular currents. And that basically is another cue as regards to highlighting the past storm event. This image, you're now seeing those larger boulders, and the gentleman in the image gives relevance to the scale. And again, now what it is that you should be able to see is the general imbrication or the tilting of the rocks that basically indicate that the flow of the river would have been from left to right in the context of the image. And you can also see that there exists that what considered as vegetation, older vegetation, and how it basically has been pretty much parked by the trunk of the tree, right? So these images give us a tale of the capacity of the river to basically produce in the current and future storm related flooding, or the kind of size of flooding that basically can be hazardous to nearby, uh, let's say, investments or infrastructures. So this is giving you the insight that where you build, if you do build on a floodplain or if you do build beside a river, it is key for you to basically have sediment analysis done so that you can be able to have an understanding about the past capacity of the river flood and whether or not it is likely for it to take place in the future, depending on basically what you see from the sediment core as well as how far you are from the riverbank itself. It can give you insight in terms of where you should build, how you basically should provide some form of reinforcement and other kind of engineering cues to retrofit and protect your investment. All right. So yes, this is basically where you pretty much can move on with this insight, this information, and hopefully make much more informed decisions in the context of your infrastructural development interests.